So as we discussed various types of machine learning, now we will look at various algorithms, different algorithms, but we will start with linear regression. Okay, so the first and foremost is this term linear. Okay, what is meant by linear? Linear is nothing but if one quantity increases, the other should increase. Okay, so if one increases, the other increases. If the other decreases, another one decreases. And if one increases, the other could decrease, but there is a caveat here. The caveat is they should increase or decrease in constant rate. Okay, so they should increase or decrease in constant rate. So that is when we call it two variables are exhibiting linear relationship. For example, if you take it on XY plot, if this is your height, as a child grows, child's height increases, right? And likewise, weight also increases. This is weight. As a child grows with a certain age, it will start to exhibit this type of phenomena. So something that is increasing constantly. Okay. So with age, let's just say this was the age at 5 years. Okay, somewhere around, let's just say 2 years. For 2 years, let's just the weight maybe 10 kilos. Okay, maybe at 5 years the weight increased to something else. Okay, at 15 years the weight is something 40 maybe. Okay, or and let's just say at the age of 17 or 18 or 20, the weight is at 50 or 60 kilos. Okay, so this way there should be a constant increase, not sudden increase. Okay, or not a sudden decrease. Okay, or not a increase or decrease kind of relationship, or not something like first it increases then decreases, something like quadratic. This is called as quadratic. Okay, not quadratic, not exponential, not logarithmic. Suddenly from it was high in the beginning and then it decreased. So not logarithmic. Okay, not cosine or sine relationship. This is sine or cosine relationship. Okay, so not these type of relationships, only something that increases constantly. That is called as linear relationship. Okay, and we apply this linear regression algorithm. Regression means you are finding out the end value, which is a float value. Okay, you have to find out a float value with the data that exhibits a linear relationship with the target variable. So x should have linear relationship with y. Only then you can apply linear regression. Okay. Now how do you measure it is the question. The question is, how do you come to know what relationship this x has with y? Very, very simple. That is why you have scatter plot. How the data is distributed, that you will realize. So if the data is increasing like this in this direction, okay, then it is a linear relationship. Although the points are moving here and there away from this line, but it is still linear relationship only. Okay, you can't expect everyone to be 40 kilos at age 16. No, that is not possible. Okay, some could be, some variables could be 50 kilos also, some could be 30, some could be 60, some could be 70. So it is possible. So these points will be somewhere scattered like this, but nevertheless they will still exhibit a certain exact relationship, a linear relationship. Only in that cases you will apply a linear regression algorithm. Okay, what linear regression algorithm is measuring is the linear relationship between, okay, I mean, what a linear regression algorithm is predicting is the y value when the given relationship is linear between x and y. Okay, it calculates y on the data, but provided the relationship should be linear. Okay, now let's look at certain concepts before moving understanding linear regression, which are very, very important. So types of relationship, this is what I was talking about. So let's just say there is a player who played, let's just say shuttlecock or some badminton. So they played, or how many minutes did they play? So this is what is measured against how many points they scored. Generally, for most of the players, it would be a straight line like this. Sometimes it could be slanted line like this at certain angle, but nevertheless it will be straight line. So these type of relationships are linear. Okay, the relationship could be linear, relationship could be like this also. Okay, either it is like this or it is like this. Okay, or it is like this. These are all linear relationships. Okay, but it has to be a straight line. As you can see, it is a straight line, straight line, straight line. So whenever you see data moving in a straight line, it is a linear relationship. Now what is meant by non-linear relationship? Some examples we will see. Let's just say one example is total working hours per week versus overall happiness. Okay, your happiness increases on Fridays, right, and decreases on Mondays. So number of hours, how many hours versus jokes aside, so number of hours per week versus overall happiness is measured. This is a metric, literally a government metric in Europe. Okay, they measure how much, how happy are their citizens. Okay, this is a government metric, by the way, in certain countries of Europe. So how many hours? So it is, upon doing this investigation, they have found that if a person who works at 40 hours, he will reach peak happiness. I mean, up until 40 hours, he will be happy only. Okay, and if a person works for lower number of hours, then also he will show very less happiness. That is what happens when you put an employee on bench for long hours. He is not working, he is getting paid, but he is still unhappy, right? He is unhappy because he is not having work. So that's how humans are designed. Okay, so if you give less work also, then humans will be unhappy. If you give very high work also, then humans will be unhappy, although the reasons for unhappiness could differ. But this is a relationship you can see. First it increases, then it decreases. So this is what we call as inverted U or U relationship, right? So this is your linear relationship. This you understood? Okay, let me write it here. So linear
Yes.
is this,
Straight.
yeah, straight. Okay, this is linear relationship. Okay, now quadratic relationship is something that U-shaped, increases, decreases. Okay, first decreases, increases. This type of relationship is quadratic relationship. So you can see U-shaped of relationship. So this is quadratic. Okay, quadratic means again one more thing is, for linear relationship you can measure linear relation. You can see the very mathematically you can see it exhibits a straight line, right? So here straight line equation will apply. Y is equal to mx plus c or b, whatever you apply, mx plus c. Okay, so this will be the equation. Quadratic equation means y is equal to ideally y is equal to some mx square. Okay, squared. This square term indicates quadratic. Okay, let me write the general equation. Okay, general equation is this. You must have seen in your high school, ax square plus bx plus c. This is the general term, general equation for quadratic. So mathematically, if you want to measure this relationship, you have to apply this equation. Mathematically, if you want to measure this relationship, you have to apply this equation. Okay, likewise you have cubic relationship. This is also one of the non-linear relationships. Okay, non-linear relationships is you see, you will get to see like this, a kind of S shape. Okay, so we don't have a good example, but there are a lot of relationships in thermodynamics that exhibit this relationship. Anyway, so if you get some S shape, then you get a cubic relationship. So this is cubic in nature. something like this, okay, or something like this also. Okay, so these are all cubic relationships. Next comes exponential relationships. Exponential relationships is your money growth. Okay, let's just say there is a constant increase in the world money, okay, amount of money in the world, and you have invested some amount in some stock, or some invested some amount in some FD, which increase your money at constant rate. But because your money is compounding, okay, so you can expect in the first year your money will be here, somewhere here, some amount of money you have invested in first year. Second year here, okay, third year here, fourth, fifth, sixth, okay, up until it reaches 10th. By the time it reaches 10th, the money factor, the money factor, this is time, 10 years you have spent, okay, and the money has grown by a certain amount till here, okay. Let's just say some 5x it has increased, not even 5x, let's be realistic, 3x it has increased, just for the sake of argument, okay. But in next 20 years, if you keep your money for the next, because you already have gained huge amount of money accumulated, now it will seriously increase in next 20 years. Now this would be not 3x, and 3x would be, ideally it has to be 6x, but it won't be 6x, it would be somewhere around 10x, okay, 10 times your money, whatever. And if you keep it for another 10 more years, so that is 30 years, then you will see a further surge in the wealth. Now this will be like 40x or 30x, whatever, okay. So if you measure this, here it increased by 3 times, okay, here it increased by maybe this is 40 years, more than 3 times, okay. That is what I'm trying to say. So your amount keeps on increasing. That could be one exponential relationship, okay, money compounding. So if you keep on putting money in recurring deposits for over a period of 30 or 40 years, you would literally be a crorepati, okay, no doubt in that. That's how money works. So that could be one relationship. Another example is where bacterial growth, okay. So we went through hell of a time, right? COVID time, the world went through very bad timing. So COVID, talking about COVID, you will see that the relationship that you see in the bacterial or viral growth is again exponential in nature. For the first second you will see only one virus. For the second for next few milliseconds you will see 2, 4, 8, 10. That way it will keep on growing. It will grow up to some millions or billions or even trillions of bacterial viral cells. So that is another relationship that you can get to see in nature, that is exponential. If you see like this, it is exponential, it is increasing much faster, okay. So that is exponential. Next is logarithmic. Logarithmic is also non-linear relationship, okay. So one example is given is efficiency of smart home technologies. For example, if you're wearing a smart watch or even using an iPhone or some Android phone, which are all smartphones, the battery depletes, right? So the efficiency decreases over time. First it would be, this is given as ulta. First it would be, let me draw. So logarithmic means it should be either like this. First it should be increase and then it should decrease, or first it should be more and then it should increase, okay. Something like that, okay. I think I have drawn, 1 second, okay, something like this, okay. So this is logarithmic relationship. Now here what happens is, if you're using your smartphones, if you look at your battery efficiency, first few years it would be 100%, which is this case, 100% it would be there, and over the period of time it will keep on decreasing. Likewise, your efficiency of your cars also, right? Efficiency on the first year, it will be at 100% efficient. Fuel mileage, everything will be high. As the time passes, your efficiency will only go down. Okay, after a 15-year-old car, you can't expect the same efficiency and same functioning as on the first year. So this is logarithmic relationship. Okay, so here they have shown it as ulta. Actually, ideally they should have shown like this, in this way, but anyway, they have increased it. Ideally it decreases anyway. Okay. Next is cosine relationships. Cosine relationships are wave based relationships. For example, if you want to work on signal processing, text to speech, speech to text, okay, you need to tackle the various, or maybe even heart rate calculations you want to do, okay, basis on the graphs that it generates. So all such places you will have to properly make the model learn that pattern, whatever the pattern is, cosine pattern, sine pattern, or whatever the heart rate pattern is. Okay, heart rate pattern is something, it will increase, decrease, and then it will go down, right? So those patterns we have to learn very well. So you have to teach the model to learn the, teach as in the model will automatically learn from the data, that's a different thing. But such relationships exist in nature. So this could be cosine, this could be cosine. Sine means it will increase from here. Cosine means it will decrease. Okay, it will halfway, it will start and then it will go to 1, okay, in the next set. But sine is not like that. In the first itself it will go to 1. So that is the minor change between the angles of the waves. But otherwise it is cosine, sine, tan, or whatever the relationships are. So all these exist. These are all some examples of non-linear relationships. Now that you know the type of relationship the data can exhibit, you will do a scatter plot and you will look at the data, what the data is telling you. And once you understand the type of, just by looking at the graph, you should be able to tell what type of relationship it is. Okay, if it is this type of relationship, it is quadratic. If it is moving in one line, it is a linear. If it is quadratic, you can't apply linear regression algorithm. Okay, you can apply linear regression algorithm only if the relationship is linear. Is this understood about the various types of relationships?
Yes.
Okay, next thing is, the next concept you have to understand before going to linear regression is the concept of slope and the concept of intercept. These terms, that M and C. Okay, M is called as slope. Slope means what? A hill slope. What do you mean by hill slope? This is the hill, this is the slope, right? Slope means the slanting side of the hill. So basically, if you I mean not on the hill, but if you have some sort of kids playing some equipment, right? Okay, so if a kid sits here, what will happen? He will slant, he will come down and he will reach here, right? So what do we call this side? It is called as slope because it has certain angle to the ground. This angle, it has certain angle to the ground. The angle could differ, 30 degree, 60 degree, 45 degree, whatever it is, whatever the angle is, but angle doesn't matter, but it has certain. So hence we call it as slope because you sit here, you come down. Okay, so here we want to understand how is this slope functioning, what is this intercept, before even going to linear regression algorithm. Very, very important. So in order to understand, let me first make this as 0. Everything I will make it as 0. Okay, this is 0. This is 0. Okay, now you can see the red, the line is on the x-axis. Okay, slope means the angle, you are trying to control the angle of the line. Okay, you're trying to control the angle of the line. What I essentially will be doing is, if my data is like this in this direction, dot 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 in this direction, I want my line to be in that direction correctly on that data. If my data is coming from top to bottom like this in this direction, okay, then I want my direction of the line to be in that direction, in that same direction. Okay, next is, once I get the direction right, let's just say this direction, now if the data is here, I can't have my line here. I have to fit the data on the here only. Okay, if my data is here, okay, my line should be on top of that data. How do I control that? By moving my line using intercept. See what intercept is doing. Intercept moves the line on the data. If my data is here in this direction I got it by adjusting the slope. Now how will I adjust the how will I bring the line on that particular data? By controlling this intercept. I will bring it here. If my data is here, I will bring it here. If my data is here, I will bring it here. Okay, if my data is here, I will bring it here. By controlling the intercept, this term. Did you understand this concept? Intercept and slope.
Yes.
Can you please repeat intercept?
Sure. Intercept means, okay, let's just say my data is here. I have this data, no? This data, straight line data I have. Let's just say I took the height. Okay, I took the height versus target variable. Let's just say how much marks he will get basis on the height. Okay, I know it sounds stupid, but don't worry about it, just for the sake of explaining. Let's just say with increase, or maybe how much height versus not the marks versus the performance in sports. How well the student will perform in sports basis on the height. Okay, this up to certain extent makes sense, right? So let's just say this we measure. Now with increase in height, we see increase in stamina in kids. With increase in stamina, they can better sprint. Okay, they can run better. So let's just say that is the observation we have found out. Now my straight line that I am using, okay, should be able to, I have to control this. See, first of all I have x. X is height. X is height. Y also I have. Y is my sports performance. Okay, X I have, Y I have, but I don't know what is my M and C. Okay, now my job is to do a scatter plot. After doing a scatter plot, I find out that with increase in height, stamina is high and kids are performing better in sports. I should be able to fit the line like this, no? In order to capture that relationship correctly, I have to fit the line, no, on top of that data. Correct? Do you agree? In this way I have to fit. How do I fit it?
Correct.
I can't manually fit it. I have to make the algorithm fit it. Okay, I have to make the algorithm automatically learn. Sometimes the data would be like this, no? If I manually fit the data like this manually, if I do it, what if I measure weight? Okay, it's a different relationship. What if increase in weight is causing people to run slower, which is true up to certain extent? The relationship will be like this, no? Now I can't take the same line and fit like this. It is meaningless. It is not capturing the relationship. I have to make the model learn this very well. Okay, so basically I have to make the model automatically learn these relationships. How do I make it is the question. By controlling this slope and intercept. What does slope do to a straight line is, if you increase the slope, you can change the angle. You see, yeah, I can change the angle and I can move the data. Now I can capture this relationship. Weight and sports performance I can capture. Weight and sprint, 100-meter sprint I can capture. Okay, That means increase in, you can very clearly see here, increase in weight. If the weight is high, I mean here it is 10, but for the sake of argument, I assume this is 100. If the weight is 100, then the people, they are not able to run. They are taking, I mean, they are not exhibiting good stamina, or maybe they are not able to run faster. But as the weight decreases up to certain 60 or 40 kilos or 50 kilos, you can see the stamina is increasing. I mean, not the stamina exactly, they are able to run. Okay, they are quite swift as compared to people of 100 kilos. Okay, so that is what this line is talking about. Now what if we want to switch back to another variable of height? Okay, that has to be controlled again. Okay, that has to be controlled in a different direction. I have to change the slope, I have to bring it down, and all of this has to happen automatically. I can't manually keep tweaking for every variable. Okay, how that is done automatically is a different thing we will learn, but the point I'm trying to make here is you can do that by adjusting this M and C. Now how do you know how much to adjust? That's a different concept. How much to adjust automatically is a different concept we will learn, but essentially to learn that linear relationship, you are tweaking slope. We call it as slope, and here we call it as intercept. This is intercept. Okay, so we are controlling slope and intercept in order to get that relationship right. Okay, that is how we are capturing the relationships. Is this concept clear? Slope and intercept.
Yes.
Okay, all right.
Yes.
Okay, all right. Next is the concept of loss function. Okay, again talking about M, we have to, so this I think we have already talked about. If M is greater than 0, okay, that means if your line is like this, it is lying in positive quadrant. If you calculate the slope here, how do you calculate the slope? So this slope, I think you must have studied this in high school, no? If this is your slope, you can calculate that by taking the height of this triangle and base of the triangle, okay, by taking their division. You divide this by this, you will get certain value, and that is how you get the slope. You will get the slope. Nothing but if you want to calculate the slope, okay, you will have to your Pythagoras theorem will apply. Okay, here anyway I will talk about it in depth, but just for the sake of argument, we just understand if your slope is positive, that means x and y are having positive relationship. If M is decreasing, not negative, okay, they are having negative relationship. That much you remember for now. How we calculate and how we show all of that, I will show you. And next is this intercept that we talked about. Okay, so this intercept is very interesting thing that we talked about. So different people have different way of interpreting this. Although intercept is controlling the where the line should start. Basically what intercept, if you pay attention, intercept is, if I say intercept is 4 here, what essentially it is saying is where this line is cutting this y axis, that is what it is saying. See, 4, at 4 it is touching that line. So if I increase it, sorry, not this one, if I increase it to 7, let's just say 7, if you notice it is touching the y-axis at 7. So intercept is essentially the line, the intersection point of that line on the y-axis. What is slope then? Okay, this is your, this we understood, this is your y-axis. Now what is slope? Slope is controlling the angle. Slope is controlling the angle with respect to x-axis. See this angle? wherever it touches the x-axis. This is your x-axis, right? So look at the angle. Okay, now if you measure here, the slope would be negative. How do you measure that we will see, but here usually if you notice, for this direction the m is negative. Okay, for this direction m is positive. So basically in your mind what you have to remember is, if you have from lower to upper, if the line is going, then slope will be positive, m will be positive. If the line is coming from top to bottom, the m will be negative. That much you remember for now, that is more than sufficient. Okay, that is the next thing that you have to understand. And the next concept you have to understand is loss function. Okay, okay, fine, you figured it out, you figured out m and c value means you already know where the line should touch on the x-axis. This is c. Immediately from this graph you can see, you can tell c. What is c? It is something like 6. Okay, 6 or 6.5, whatever it is, this value, it is intercept. And what is slope? Slope is, you have to calculate that you keep it aside. Now next is loss function. Let's just say you manage to fit the line. Okay, now there is another challenge. Okay, the challenge is, in this very same points you can have the line like this, you can have the you can have the line like this, you can have the line like this, on the same points only. Okay, you can have the line very something like this. All these 4 lines are connecting the same dots only, but which one will you tell is the right line? Which one is will you tell is the line that can be the best answer? Okay, how do you tell that? That you can tell by measuring something called as loss function. So what you are essentially doing is, you have lot of points like this. Okay, you are fitting a line, which is okay. Now to tell if this is the right line or this is the right line or this is the right line, what you will be doing is, for each for this line, first you will draw. Okay, first you will blindly draw a line somewhere. Let's just say I have drawn a line. Okay, this is literally how model learns. Okay, that is what I'm explaining. How model works is what I'm explaining. Literally it blindly gets some answer, some line it will draw, some value of m, some value of c, it will get it. Okay, and then it will start to calculate the distance between this point and the perpendicular, the shortest distance between that point and this point on the line, it will calculate. And then this distance it will calculate. Okay, the algorithm, then it will calculate this distance, then this distance. So it will calculate all these distances, and whichever distance, I mean, it will take the again, if it calculates the distance from this point to this point, notice something, this point has y value as high, x value as low. Okay, and this point y value as, this is y this is y dash. So this point has y value as low but x value as high. Now we already know that the formula to calculate the distance between 2 points, that is given by, I think this you must have already seen, x2 minus x1 whole square plus y2 minus y1 whole square. Very standard formula. I'm not sure if you remember from high school it was taught. It is also called as Euclidean. Actually it's called as Euclidean distance measurement. Okay, so that is what you are calculating, that you are calculating the distance between this point and this point. Okay, to calculate that you will simply subtract these 2 points and you will get some value, some scalar value, you will get some distance, some, let's just say some 1 centimeter it is, that is the distance between these two. 1 or 2 centimeters is the distance between these two points, and literally like this it will calculate all the distances between all the points, okay, and which final answer, after calculating all the distances, it will take the average of it. Okay, it will take the average of it, whatever the average you get, some value you will get, no, average, on average all these points are so many centimeters away. It will take that value, whatever, let's just say 1.5 centimeters on an average, all these points are away. Then it will draw the best fit line. Okay, then it will draw the line. Now it will compare this distance, okay, with the actual values, with the actual points, how far away. Okay, so when it compares, it will have certain difference, no? So y value minus y cap will have certain value. It will be compared with this. Okay, forget the average part for now. Okay, not the average. It will start comparing at individual level. Let's just say, let's talk about loss function only, not the cost function. Whatever the distance you got, it will be compared with this original point. Okay, if the difference is too high, okay, let's just say the difference is 0.8 centimeter, and in the next attempt what it will do is it will try to minimize this difference by readjusting this line. It will change the slope. So what it will do is it will draw this line like this. Slope it will modify, intercept it will modify, and then redo the calculation again. It will get some difference. Ideally the difference would decrease. Okay, it got 0.7 as difference. Again it will readjust the difference. It got 0.6. So the goal is to reach close to 0. Y should equal to y cap. That is the goal. Okay, although you will never see that happening, the answer could reach to 0.001 or 0.1, whatever. So whatever the line that minimizes the distance between these points and the line, that line will be taken as best fit line. Okay, ultimately you will get some line which would be called as best fit line. Okay, best fit line. Okay, did you understand this concept? Minimizing the distance between the points and the line, and difference is reduced to almost 0, and whatever the line, whatever the value of slope and whatever the value of intercept is able to decrease the distance will be taken as the best fit line. Did you understand this?
Yes, sir.
Okay, so that is what is happening here. First the line would be plotted like this. You have dots everywhere, and the distances, the straight lines, thin lines are the distances, and whatever the distances are measured, the difference is taken. And how there are different ways of taking the difference, okay, by the way. So whatever the difference is taken, that would be called as your loss function. And like I said, sometimes you can take the mean absolute difference, then it will be called as mean absolute error. Sometimes you can square it, and then you can call it as quadratic loss. Sometimes you can take the log of it, sometimes quantile of it. Okay, different ways of calculating. Sometimes root of it, root of square of the error, that would be called as root mean squared error. And finally, ultimately, once you have loss function, you will take the final average of it, and that would be called as your cost function. So you are essentially saying, on an average, my best fit line is so many points closer to the dots, that are data points that are available on the plot. So that will be your cost function. You can again further adjust. If you are not getting sufficient answers, you can further adjust this cost function by adding additional penalty. we call it penalty. It's a fancy term, but all you are doing is you are increasing the complexity of capture. So that we will learn. Don't worry about it. Again, easy concepts only. So you can further manipulate this cost function and loss function, and finally you can get the better average, lesser average, okay, of the cost function. Okay, so that is called as penalty terms. L1 regularization, we call it regularization. Like I say, I mean, mixture of all these group of people like mathematicians, statisticians, they like to use their own terminology. That's why you get regularization, penalty terms, so all mean one and the same only. Okay, so you will get the better. So don't worry about this complex formula. It's very simple. I will simplify it down for you. Okay, that is another concept. Then there is a concept of learning rate. Okay, gradient descent and learning rate. Now fine, you figured it out, the least amount of line. Okay, least amount of line, you figured it out. How did you figure it out? By calculating this subtraction, this one, by comparing it with the original value. Okay, you took the complete rows of data. Let's give it a thought here. You took the complete rows of data, then you took the y values which you already had. Okay, you equated this, then you got the slopes m. Okay, this is x, this is y, this is m. What is the straight line? Y is equal to mx plus c. C you ignore. We always ignore the c. Don't worry about the c. C is usually very small value, so we don't generally talk about it. So mx, y is equal to mx. X values you already had, y values also you already had. Okay, then you got the m values, you figured it out, the m values, simply by, this is a dot product. Now simplify. How do you get the, by taking a inverse, by doing a inverse calculation. Okay, you don't have division in matrices. I'm sure you are aware of this, right? When we learned about matrices, nowhere we talked about division. We talked about inverses, right? We talked about inverse of a matrix. Okay, if you multiply A into A inverse, you get identity matrix. This is what we learned. Nothing but, okay, what will you get if you divide 2 divided by 2? You'll get 1, no? 1 is your identity matrix, a matrix consisting of only ones along the diagonal, and A is your some matrix, some with some value. Now there exists A inverse, upon which multiplying A to its original form, you will get identity. Okay, so division is equivalent to inverses in matrices. Okay, again I'm recapping this. Now what you will do is, how will you get this m? Y x inverse. Okay, y into x inverse, product of these two will give you the m value. Okay, whatever the mechanism is, it doesn't matter. I mean, we don't have to learn this in depth, but I'm just saying that you calculate this m. Once you calculate this m, okay, you properly train the model. Now the model knows m values. Okay, now you can change the x values and get y dash. Okay, let me write this properly. First you had x values. X values you had, rows of data, whatever you have. These are the rows of data you had. And then you equated that to y, which is your target value. This also you had labeled. These are the labels. Cat, dog, 0, 1, 2, whatever, 1.1, 2.2, whatever it is. X equals to y you know. And you found out linear relationship, hence you wanted to calculate m. This you didn't know initially. In the next step, what did you do? You calculated m using, okay, you sending x to that side. We don't have division, we have only inverses. You got y into x inverse, you got m values. Now you know m. Pay attention here. You used up all your information already. You used up all your information to find out m. Now whatever the m you got, okay, whatever the m you got, right, okay, if again you are doing this for multiple rows of data. Anyway, 1 second, I think there is one concept. Okay, so you got the m part figured out, but how do you know whether whatever you have obtained is a generalized answer? For this data, this is the right answer. For whatever x value you had, y value is the right answer, and m is also the right fit. But what if x changes? X changes by slightly little bit. Then does your m hold true? No, right? It also has to change a little bit. Okay, and if x further changes by a little bit more, m again has to be readjusted. Correct? That is how it is. Now, what I'm trying to say is that whatever the m you have calculated, it is not generalized answer. It is not general answer. It is a specific answer. What we want is a general answer that can be applied for all the cases. So, to apply that m for the general answer, to learn that m, you have to go back and relearn the data, relearn from the data. Okay. Now, this process has to be repeated until, I mean, once you calculate the m, what you will do is you will subtract this y and y dash. Either you will take the square of it or absolute value, is up to you. But once you get this answer, certain value, let's just say 3 has to be closer to 0. Okay, right now it is not closer to 0, it has to be made to 0. So what you will do is, you will tweak this m values little bit. You will change, you can't change x because x is given for you, y is given for you. The only thing you can change is m. So you will tweak little m value little bit so that this becomes 2. Okay, then again you will go back and again you will compare, again tweak this value, and so that this becomes 1, so that again it becomes 0.5 or 0.01, whatever it is. So you will keep on repeating this process until you get the right generalized m values. Okay, so this is the process. Now gradient descent, this is where gradient descent work comes into picture. Okay, gradient descent is another optimization algorithm to find the minimum of a function. So mainly the loss function. This is your loss function. This is your loss function. Okay, this is your loss function. To decrease this loss function, you will apply a optimization algorithm. What you will do is, you will convert this entire process of learning into a optimization problem. So what you will do is, see, in the first run, before adjusting this m values, when you calculated m value, you will start plotting that slope. Okay, you calculated the slope. Okay, you got the slope is the average of all these m values. So you got the slope value, and you also calculated the loss function. You will start plotting that loss function along the here loss function. Okay, sometimes you can plot the loss function, or you will plot the you will plot the loss function. Okay, initially the kind of relationship it will exhibit is, you will start to see like this. Loss has to decrease. The difference between these two is nothing but loss. That has to decrease, that has to come down to 0. Okay, initially it will be high, that loss will be high, slope will be high. Slope will be high, intercept, this is I mean no concept of intercept, this is slope now. So slope will be high. Okay, so your idea is to manipulate this slope to bring down the loss at a certain extent, like this. Okay, now the question is, okay, fine, you know, there is one challenge here that I'm trying to highlight. Now the challenge is, how do you know how much to adjust this m to decrease this loss? That is the real challenge. That is where usually that is why optimization algorithm comes. So how much to adjust to bring down this loss? If you adjust little too much, this loss will go up. Okay, loss will go up. And if you adjust little bit low, this loss adjustment, this loss will come down. So that is why what they do is they plot slope versus loss. At certain slope, the loss would be high. Okay, it exhibits this U structure. If you increase the slope, okay, loss would be certain value, and the best part is to bring it to certain optimized value. Now, how do you know how much to alter this slope is the question. For that is where we have something called alpha, also called as learning rate. Okay, learning rate. Learning rate, you will remember this learning rate. You will encounter this learning rate in almost many algorithms. Okay, so learning rate is alpha, which usually ranges from 0.001 to 0.1. Usually this is its range. It's very small value. Now small value is the value. Now the way how I'm trying to decrease this m, to decrease this loss value, is by multiplying this with a very small value, 0.01. If I multiply whatever the value of m, I'll get, m was 3. Let's just say slope was 3. If I multiply 0.01, how much it became? It became 0.03, no? Now if I subtract 0.03 from 3, now my m value became 2.97, right? It went from 3 to 2.97. I decreased 0.03 from 3. Likewise, I'll keep repeating this process. I'll keep on manipulating this m value until I get this loss as closer to 0. Okay. So that is what this gradient descent means. Gradient descent is nothing but, okay, decreasing the learning rate. Learning rate is just a term, some arbitrary value that you are going to multiply to the slope to decrease its impact on the loss. Okay, why you are multiplying with slope only? Because x is fixed value, y is fixed value. Okay, it is already given values, observations. X and y are observations made in the nature, made in the sensors or some process. They can't be changed. The only changeable value is m. Okay, and m you have to decrease or increase by small factors so that your loss comes to 0. Okay, if for 2.97 m, the loss could be, let's just say it came down by, from 3 it went down to 2. Again, if I further decrease it by 2.6, 0.03, I have to keep decreasing. Essentially 2.94 maybe. Again 0.06. Again it will decrease it to maybe 1.5. Okay, this way it will keep on decreasing. It will come down to 0. But after certain rate, after certain manipulation of this m, the loss will keep on increasing again. Ideally, I think this has to be slope. Slope is on the y-axis and loss is on the x-axis. Then it makes sense. Okay. Anyway, however you plot, doesn't matter. So loss will increase further if you increase the slope by certain element. If you decrease the slope by further, again loss will increase. Okay. So only there is a one good point where slope is low, slope at certain slope, loss is minimum. That point we are finding out using alpha, by manipulating the alpha and multiplying with m. Okay. Did you understand this process? What is happening?
Yes.
Okay. So the whole game is to decrease this loss. So y dash is your prediction. It has to come closer to your y. Nothing but their difference has to be closer to 0. And to get to 0, you have to manipulate m. because you know mx equals to c, you can't touch x, you can't touch y. The only thing you can touch is m. So m you have to manipulate by decreasing. And in the back end, what is happening, you know, when you're doing all of these, if these are your points, in the back end, what is happening is, each time you multiply alpha to that m, if this was your original line, after multiplying alpha, what is happening is, the line is changing by a little bit. Okay, again you multiply further alpha, again the line will change by little bit. This is what is happening in the back end. This is how you are controlling slope of the line by multiplying alpha. It's a game of just multiplication. Okay, is this concept clear?
Yes.
If you have understood this,
And this is what gradient descent is doing, right?
yes, gradient descent is just an optimization iterative algorithm. It just finds the minimum of the loss function, okay, by just multiplying some alpha to the m value. And for each iteration, you will keep changing the alpha value. Now, what you see here is, if alpha is too small, it will take you will get the answer, but it will take too much time to get to that answer. Okay, time will be very high. That is why you have to get the alpha correct. And if the alpha is just right, I mean, if you are iterating very quickly, I mean, in at a decent speed, then you will get the answer correctly. If your alpha is too high, then you are changing the slope in a very high number. That means you will never get the loss function, minimum of the loss function. You will never get it. So that's why this alpha, we call it as a hyperparameter. Okay, hyperparameter is the parameter that is unknown initially when fitting the model. Okay, we have to find it out. Is this clear? This is called as gradient descent.
Yes, this alpha means your learning rate, right?
Learning rate, yeah. Usually it is it ranges from 0.001 to 0.01. Okay, that is its range. So, and once you reach that alpha value, once you reach the minimum slope, and final minimum slope means loss value is very, very low, we call it as convergence. That point is called as convergent point, or we have already reached the global minima. We also call it as global minima. So convergence, global minima, so is just convergent point and global minima. They are one and the same. Okay, don't worry about this formula and all. We'll come back to this. This is what I said. From slope you will subtract the smaller version of I mean, you will multiply that alpha. That is, initially if your slope was 3, okay, you will multiply slope with alpha 0.01. So 3 minus 0.03. Now you will get 2.97. Okay. This will be your next slope. Again you will multiply, subtract and multiply, minus 2.97 into 0.01. Okay, so this way you will keep on decreasing the m value until you get the minimum loss.
Minimum.
So here it is shown, as you can see. See, this is how it fits. First it adjusts the m minus c value until you get the, in the back end it is calculating the cost function. It is subtracting the y minus y, also doing the distance calculation between those points and the line. Okay, so this is how it works. Automatically it adjusts.
So initially when it take the learning rate, it will take any random value, right? And
learning rate we will specify. Okay, it's by default learning rate also is automatically specified as a default parameter if you don't specify. Okay, but you can specify, you can change the parameter.
okay.
Yeah. So if you have understood this, then linear regression is done. And if you have understood this concept, neural networks also you can understand easily. Okay, they also work on the very same process. Now this is whatever we talked about. Is all this we talked about, if you noticed, we talked about only by taking height and sports performance. That is what we talked about. Now this process is repeated. Okay, this process is repeated for multiple rows of multiple columns of data that you have: height, weight, okay, place of birth, diet, whatever columns are provided to you. This process is repeated in a way that instead of line you will have a plane. Now this plane has to be adjusted to fit those data points. Okay, so we call it best fit plane for multiple linear regression. You don't worry about this, even if you don't remember. Generally, multiple linear regression itself is linear regression in our case, because we will have multiple columns of data. Okay. So the equation is no longer mx plus c, but instead the equation is m1x plus m2x plus m3x. So this way it will continue. Okay. So you have multiple m terms now. Is this clear?
Yeah.
Okay. So this way it will look. It will be a plane. The plane will it will start at a certain slope. Okay, randomly initialized slope. From there it will keep on multiplying the learning rate to come down to the least minimum point. And what you have on the x-axis is the slope. Loss function. Sorry, what you have on the y-axis is the loss function. Loss function is being decreased, and what you have on the x is the slope. So the loss keeps on decreasing. Okay, this is the linear regression. Up until this point, if you have learned, then you have covered major complex concepts for linear regression. Okay, so I want to stop till here.